Welcome, everyone. We're just about ready to get started. It's 11:59. We're just going to wait a couple more minutes here, and then we'll get started on our Wi-Fi tips and tricks webinar. It's great to have you here. Thanks for taking time out of your day. I think you'll learn a thing or two. I think it'll be helpful. Just setting up behind the scenes here a little bit. This is about a 1-hour presentation, give or take. We'd like to be done right at 1 p.m. There'll be room for you to ask questions. There is a chat feature in this, and so if you have questions along the way, I will be moderating that. We'll be looking at your questions, and there may be times when the question comes up that we're going to cover a little bit later, and we'll let you know that. But we encourage your questions. This is for you, not for us, and we think this will be pretty helpful. And we'd love to tailor it to you, whatever your questions are. First things first, for the people that are here, I just want to make sure, can you hear us? Do you hear us? If you could raise your hand virtually, that'd be awesome. Be good to know that somebody can hear us. Hey, look at that. Got Liz. Anybody else out there? Hey, thank you so much, Scott. Appreciate it. All right, well, let's get started. Welcome, everyone. It's great to have you here today. We are so excited. We love this presentation. We think it helps out a lot of people, and it really makes a lot of sense with all the stuff that's going on with Wi-Fi these days. Presenters today are myself, Chris Merchant. I'm the sales manager at Waitsfield and Champlain Valley Telecom, and I've been doing that for about 29 years, which is amazing. Doesn't seem possible. Like Richard said, I started when I was 18. And then we have Kurt Grundling. He's the Vice President of Marketing and New Product Development. And Kurt will definitely be doing most of the heavy lifting today on this presentation. And Kurt is great. He's not just a marketing guy. He really loves to play with all the latest and greatest little technologies that we have. So he's a driving force in any new products that we have. So we should also know you should be our new product development manager as well. Yeah, actually, you are in there. That's perfect. All right, well, great to have you. Kurt, take it away.
Thanks, Christian. Thanks, everybody, for joining us today. I think we have a lot of information to present that we'll run through. And as Chris said, drop stuff in the chat and we'll answer questions as we go along. The last slide, Richard was supposed to join us today, but I think he saw the sun was out and decided to do something outdoors instead. No, I'm kidding on that. But he's usually on these helping us out. Many of you probably talked to Richard in tech support. But just to kind of start out, we wanted to talk about what is Wi-Fi, right? And I think, Chris, you and I think of Wi-Fi as how we use the internet, right? In the eyes of the user, the end customer, we really don't differentiate between the internet connection and a Wi-Fi connection. To us, Wi-Fi really is the internet these days. We've seen Wi-Fi just become more and more prevalent over the past decade. Years ago, right, when we were starting this in the days of dial-up, it was a desktop computer with, a ISA or PCI board that we would put into a computer with a modem or an external cable to modem, and that was just one single device. There really was no such thing as Wi-Fi in the home. But these days, most devices and even laptops don't even have an option for a wired connection anymore without using some sort of dongle. We're finding that pretty much all customers now have most, and in many cases, all devices connected via Wi-Fi with no hardwired devices anymore. So this webinar is really focused on discussion of some of the challenges and limitations of Wi-Fi, and really how we can solve some of the basic problems that come along with in a wireless world, I guess, so to speak, Chris. So just to start off with, we want to talk a little bit about, the different components that make up a home network. It seems like your home network is pretty simple, and it certainly is when everything's working, right? But you start peeling back the layers, and there's a lot of different parts and pieces to that. First off, you have that internet connection that's coming into your house, right? That's the bandwidth, right? Think of that as kind of the electricity for everything. You then have your Wi-Fi router, modem, sometimes in some cases, depending on the size of your home or business, multiple Wi-Fi access points within the network, right? And that's kind of expanding and spreading out that coverage, right, throughout your home. Um, the optical network terminal, which is part of the internet connection, and if you're a fiber optic customer of ours, that optical network terminal is what's taking the light signal that travels over the fiber optic glass and converting it to an electrical signal, that wired cable that's going into your router. Any network wiring you may have, obviously these days it seems to be more prevalent in businesses, which still have more of a wired network. You may still have for your voice line, analog voice line, which obviously we do on fiber optic as well, and right that transitions into your home network as well, or what we call a SIP phone, which is really more on the business space. We all have a smartphone somewhere, right? Whether you're, an iPhone user or an Android user on the smartphone side, but those are mini computers, right? Again, connecting to your wireless network in addition to the cellular network. Whatever type of computer you may or may not be using. I mean, in some cases, we're seeing people just strictly using tablets, like an iPad these days, not even having a laptop computer. But, I would say that laptops are definitely much, much more prevalent these days than, especially in the home networks than a desktop computer. And then any of the other various equipment or services, located through your home that make up that home network, right? Everything from, all the devices that you have connecting could be cameras, home assistants, could be printers, right? All the stuff that connect to the network. The internet connection obviously is a critical piece of the puzzle, right? It's that physical link between your home. If you're a customer of ours, it's probably a fiber optic connection these days. You might be one of our remaining DSL customers still waiting to be converted. We still have a few thousand customers to go that are still on that copper DSL network, but we're pressing hard. Probably see our contractors out all over the place, in addition to our technicians, converting more and more people each and every day, right? Just takes time. But it's certainly, I would say, Chris, when we get calls with people having problems, right? They're usually the first thing to blame is the internet connection. The good news on fiber is it really makes troubleshooting from our side so much easier, right? If that fiber optical network terminal is on, it's passing traffic, and the light levels are good, it's almost always, right, a Wi-Fi or device issue. So it really simplifies troubleshooting, which is a nice thing to make your life easier as well as our life easier, just because the reliability is so much more than the copper network is or certainly was. Most of us are using devices that connect via Wi-Fi, right? We've kind of set that stage. And we've really seen explosion in the number of connected devices the average home or business has. And I see, this is just going to continue to grow. And when you think about what those connected devices are, they're the things that we use each and every day. And then some of the things that you kind of set up once and don't even think about, right? They're just there existing on the network. And that's everything from your phones, tablets, laptops, gaming systems, could be a connected TV, maybe a streaming device like a Roku or Fire Stick, the various home assistants like the Amazon Echoes, to more obscure items. I know my smoke detectors and CO detectors in my house are all connected, right? I have Ring doorbells and cameras. Chris, was it you that got the smart fridge?
No, but I heard about those. That's kind of cool. The latest one I had is just everything. Like if you go to Home Depot and you get LED lights or something, even those connect to Wi-Fi and you can schedule them, that sort of thing. A lot of people are doing lighting on those.
And I know Richard sometimes when we do these talks about, he's obviously helped folks, whether it's an EV charger, right? On the fringe of the network, people have grills and smokers and hot tubs and all kinds of things that connect to the network via Wi-Fi, right?
Imagine being a support person having to support all of those things, tricky.
And what we've seen is, right, it used to be that single desktop computer in the corner of the home, right? And now, right, it's really the home experience has really shifted from that from a phone, right, a landline phone and single computer that was hardwired to the modem, really to the device level, right? All these connected devices, whether it's in the home or business, are all connected via Wi-Fi for the most part, and we just expect it to work. So what we're seeing, and this number actually is even higher than this now, especially as we're moving to more and more fiber. I think we're over 80+% converted to fiber these days. And, we're seeing this number that of calls that are related to Wi-Fi just go up because the fiber optic network's so reliable, right?
Mm-hmm.
But they don't really come in as, I'm having issues with my Wi-Fi. It's really, right, I'm seeing slow speeds. My internet's dropping. My TV or Netflix is buffering.
Mm-hmm.
My printer won't stay connected. So, the root cause of most of these problems these days isn't the internet connection at all. It's actually a Wi-Fi and or a Wi-Fi device problem that we're seeing when we actually get to the root cause and do the troubleshooting. And I think part of the challenge that we're seeing is, right, that homes are more complex than ever before with all those connected devices. Chris, I know I looked recently and I think, I had 37 devices in my home that are connected to my home network, which
Yeah.
is crazy if you think about just back 25 years ago, where I had a single desktop computer in the house, right, that was
Mm-hmm.
connected to the internet. Um, and we used to say more devices connecting via Wi-Fi. In many cases, it's really all
All
devices.
of them. Yeah.
Uh,
Exactly.
and let's face it, we just want it to work, right? But what we're seeing is, one of the biggest causes of slow Wi-Fi performance drops or other issues is, right, interference within the home on the Wi-Fi network, on that wireless network. So we're gonna, as part of this presentation, really dive in and just take a look at, all the myriad of things that can and do interfere with Wi-Fi and how we can optimize that home network, knowing all these complexities. So really, just to start off with, just some Wi-Fi basics, and this is all pretty common knowledge. But if you have the ability to wire a connection, it's always going to be better, faster, and more reliable than any
Mm.
type of Wi-Fi connection. So
Especially if it's critical, right? If you need something critical and uptime and always connected, if you can run a wire to it, that's the best way.
And I obviously in our homes, businesses are usually a little bit easier, right, with displaced ceilings and stuff. And oftentimes we don't mind having a wire snaked around over the floor under the desk. But in
Right.
the home, it can be a little challenging, right, to fish walls and whatnot and install those jacks. But like you said, Chris, it's always going to be far better to have a wired connection than wireless if performance and reliability is the most critical. Some of the other just basics, the farther you are from a Wi-Fi access point, the slower the speeds and the more unreliable the connection is going to be, right? It's just the laws of physics. And, the one thing when it comes to Wi-Fi is, again, we just expect it to work, but there is some science to it. But every home, construction materials, every business, right, are all different. And, the Wi-Fi is going to propagate differently within every single environment. I think the other big piece is, right, no solution is going to be perfect. And the good news is there's a lot of great equipment that we have and
Yeah.
use, and it's really advanced significantly, and we'll take a look at some of that. One of the challenges we see, especially as we start pushing higher and higher speeds on fiber, many of the devices when it comes to Wi-Fi, we all rely on speed tests, and we'll talk about this a little bit more in depth. Um, on a Wi-Fi network, you're probably never going to get that advertised speed, especially if it's in the multi-gig a bit range, where on a we can speed test right from the gateway and prove out those speeds on the network. If it's on fiber, we can guarantee the speed to the router within a home. So some of the challenges with Wi-Fi is it's a very inefficient protocol by design. It's what they call a contention-based protocol where there's no scheduling of talk time. So every single device that's connected to your network, right, is all talking. Even if you're not actively using that device. Obviously, if it's powered off, it's not an issue, but most devices stay on, whether that's some sort of security device, a wireless printer, right? They're like, hey, I'm here, I'm still online, or, whatever that data is, things in the background are getting uploaded, backups to the cloud, whatever it is. But all those devices are all competing on the network for that talk time. The other big thing is it must maintain legacy compatibility. So even though there's newer Wi-Fi standards built in and different frequencies, all your older stuff still works, right? Just because the standard and the protocols have changed and are better and more efficient, they still must maintain that legacy backwards compatibility. Otherwise, all your old devices would stop working, and I don't think any of us would be happy about that. The other thing is this is all Wi-Fi's unlicensed spectrum in the eyes of the FCC, which limits the power. So, oftentimes, I'll be talking to a customer or whatever, like, oh, can't I just get a bigger, more powerful access point and blast the signal? Well, you can, but it's not going to be any, right? All the equipment that we're using is at maximum power levels as well. And for the FCC, it's all low powered stuff anyway. The newer Wi-Fi standards that we're talking about have these wider channels. Think of them as like cruising lanes, right? Which increases bandwidth, but higher frequency, you get lower coverage. And it's really not a substitution for adding additional access points within the network. And we'll talk about what those mesh access points can look like for enhanced coverage and really optimizing your network. Chris, I'm going to put you on the spot on some of these. These are some pictures that we've installed or of installations that we've gone out of. We didn't do the installations, but at customer sites. And I guess on this one, like there's a bunch of problems with this installation that we found.
Right. Well, that's a DSL modem in the middle between the microwave and the refrigerator, and it makes complete sense because we tell people to plug in their modem right next to the phone jack because it needs that. But in this particular case, it could be really a real issue because of these radio signals can interfere with microwave. It can interfere with that cordless phone set that actually operates. A lot of them operate on the same frequency as the Wi-Fi. So just having them that close, this is an example where positioning the router in not the greatest location is going to have some problems, especially when they are reheating their leftovers. Probably not going to work very well.
At the same time, right? You're between two metal boxes, right?
Yes, a lot of reflection, refraction, that sort of thing. Yeah.
So a couple of things, right? You'd probably move that Wi-Fi access point out of there, right? Get it away, maybe a little higher mounting, get it away from, the metal microwave and refrigerator that'll be blocking that signal, move the cordless phone away as well to give that some separation, to make that a much cleaner and better installation. But like you said, I'm sure the telephone jack was right there. So it was convenient, right? Not thinking about what it might look like. So this is a point-to-point bridge that we use in some instances that this customer called in a trouble on. And Chris, I think this was you that went out on this one, wasn't it?
Yeah, it was me or Richard. I can't remember. So people are doing some really, clever things. Like, for example, these bridges, they work in pairs. So they're two wireless devices that just talk to each other. So instead of running a long Ethernet cable from one building to the next, they put these in, and they work pretty darn good. They can go a long ways. The problem is they need to have a fixed point. So I think the customer, the way Richard was talking about it, the customer was saying that their internet would go in and out during a storm or during windy days. And as you can see, if if one of these is just running all over the place, they're going to get faulty signal. But I think it was pretty clever. I would have loved to have seen that not on a sapling, but if you wanted to, strap it to an oak, that would have been different. This still would have worked.
Yeah, but funny, right, that they're calling. And there was another one I can remember too that had some point-to-point bridges that they were shooting to a property they had across the road. And
Right.
every time, like, they were wondering why the internet was dropping, and what we found was every time, like, a big truck would come by,
Right,
it was
it'd be
dropping
too
the
low.
signal,
Yeah.
right?
So
Because we
the good
couldn't
thing about this
propagate.
is there is technology that allows you to expand a Wi-Fi network out over distances. So I guess we kind of want you to see that this technology is out there, and it's very reasonable.
But again, some of the things that you really don't think of. This was an install where a customer was complaining this was their basement. I think Richard went out on this one, Chris, and they were having drops, slow speeds, and coverage gaps upstairs. And when Richard did some exploration, he went down in the basement, and kind of a cool effect. They finished the ceiling with corrugated roofing, right, metal roofing, which is
Right.
just reflecting that signal. So the main Wi-Fi router and access point was down in the basement, but it wasn't, right, doing a good job, propagating through the corrugated metal, which is going to just reflect that wireless signal. But B, if I remember correctly on this one, there was also radiant floor heat
Right.
in the ceiling there, and right, which is just tubes of water. And again, right, that's just going to reflect that wireless signal.
Mm-hmm. And in this case, the tip would be if you have a router upstairs, and we talked a little bit about how wired is better than wireless, a little bit of a combination of both. You have a wireless router upstairs, you'd run an Ethernet cable to another access point or another wireless device, put it in this room, they'd all be on the same network and it would work great. So that's one instance where, one router would not work for the whole home.
Chris, I snapped this picture yesterday under your desk.
That's not true. Maybe 40 years ago it was under my desk, but I've been better because I don't use a lot of wires anymore. I use Wi-Fi, but we have run into, imagine being tech support person and we'll tell them to, hey, could you unplug that cable? And they'd be like, which cable? So networks can be a little complicated, but also this kind of wiring and can offer some problems with interference and with wireless. So that's something you have to really control.
Yeah, you get a lot of EMI interfering across the wires, basically creating a net of interference, right, with wireless signals too, right?
Mm-hmm.
So some of the things that we just need to think about when we're positioning, Wi-Fi routers in the house, for best coverage, right, is, you think about the different building materials that are out there. Even your basically drywall, your sheetrock wall with no, like foil backed insulation or anything in it is going to degrade that signal. In some cases, we've seen it by up to in half, right? It's going to drop that signal. Obviously, things like brick, masonry, metal, all those other low E glass, all that stuff. Again, just degrades that wireless signal significantly. So you think about that in your home, oftentimes we have a TV on the fringe of the network, or maybe you're trying to connect to a, EV charger that's out in the garage, through a, fire rated wall. All these things, in addition to all the other items in your home, the refrigerators, the metal refrigerators, maybe you have a hot tub or a fish tank or, a steel rated fire door, or foil backed insulation, on, that might be invisible, in the wall. All that stuff is going to degrade that Wi-Fi signal, and lower that propagation. So, doesn't mean it's not going to work. What you're going to get is those slower speeds, that unreliability, maybe the signal drops, or maybe your Netflix, right, or your streaming video on that TV on the fringe of the network is buffering from time to time, which can be pretty frustrating, especially if it was at the end of the Knicks game last night.
Right.
So, this is the other thing that we need to just think of, right? Where we're using the Wi-Fi in the home, where we're placing access points or those additional access points for coverage. But what are those other physical interferers that we need to watch out for? The metal appliances, washers, dryers, fire doors, hot water heaters, which are full of water, radiant heat, fieldstone fireplaces, all cool stuff, but right? It's all stuff that interferes. And in fact, in older homes, which we see quite a bit in some of the downtown areas that we serve in Vermont, might be made of horsehair plaster, believe it or not. That also is going to absorb and reflect the Wi-Fi and is a physical interferer. Mentioned some of these already, some of the electronic interferers, but could be anything from your garage door openers to your cordless phones to your microwaves. The older, don't see as many of these anymore. The compact fluorescent, can't talk today, Chris.
You're doing
light
great.
bulbs, but all those things interfere with your Wi-Fi, which is definitely a challenge. So let's quickly just talk about frequencies. Kind of the legacy frequency that we all used on Wi-Fi on the older stuff was this 2.4 gigahertz frequency. It was a fairly narrow band, but a lower frequency, and it propagated the home pretty well. A lot of your security cameras, the stuff that might be set up on the fringe of the network, because right, that Ring doorbells outside is really going to look at this 2.4 gigahertz frequency. The problem is there's only 3 channels, basically non-overlapping in it, and because of that, right, there's a ton of interference and everything operates in it. Many of your cordless phones and other items are going to all operate in that 2.4 gigahertz spectrum. If you're in like a condo facility, like we've seen up by like Sugarbush when we've been in the condos up there and taken a Wi-Fi analyzer up there, it's just that those 3 channels are just totally saturated, right? Not necessarily your Wi-Fi, but everything else is also in that. Even if you can't see it right on your devices, it's all operating on those same frequencies and making it basically unusable. The newer Wi-Fi access points are operating in the 5 gigahertz and 6 gigahertz range. And as you can see here, they're kind of those wider cruising lanes, more bandwidth, many more channels that are non-overlapping, which means less interference with other Wi-Fi networks and other stuff. The problem is those higher frequencies aren't going to propagate as well. So they're not going to provide anywhere near the coverage that the older 2.4 gigahertz access points. Any of the routers, the Wi-Fi access points that we're deploying these days are dual band, in some cases tri-band. So they actually have all those frequencies, and that's what's giving you that legacy backwards compatibility. So any of the older devices that have to be on 2.4, that's there, and that's all just part of your network name, and that device is going to connect there. And then any of the newer devices are going to try to connect to the 5 gigahertz frequency if they can. And again, we have some tools that we're able to just see behind the scenes how this is operating and what frequencies your devices are using. So let's get into just some of the tips. One of the things we often hear, well, I have full bars on my phone or on my laptop, but my the internet's slow, or my internet's dropping. Probably in many cases here, right? You think it's a problem with your internet connection, but it's actually probably not the internet connection. It's probably not related to your signal strength of the Wi-Fi. So your Wi-Fi access point, your router, is going to be able to talk to your device with a much stronger signal than your device can talk back. This iPhone that I have here, right? Chris, you're on an Android, right?
No, I do actually. I did convert over finally.
Oh, you've come over to iOS.
Yeah, to the dark side.
Apple.
Yes.
But right, there's no external antennas on this, right? My hand is covering the polarity of the device. Also matters when connecting to the network. So I might see full bar strength, but this device isn't going to be able to talk back to the main Wi-Fi access point router nearly as strong as the signal coming into the device. So just something to think about there. And let's face it, most mobile devices have really poor antennas and very low transmit power. And we see the same thing like with things like smart TVs. You're buying a 50, 60-inch TV these days for a few $100. Not going to have the best Wi-Fi and antennas in it, even though, right, it's pretty critical if you're going to connect that device via Wi-Fi to have good reliability. But there's some other ways to get around that. So I would say when we look at installations, Chris, and I would say that we've become, and our technicians have become pretty much wireless and Wi-Fi experts over, just because we had to, right? It's more to support, I would say, the Wi-Fi network than the internet connection itself these days. But router location is probably the single most critical factor. And I get it, right? Like it's a trade-off in terms of where you're gonna install that, right? Fiber comes into one side of the house to the optical network terminal. It's plugged into power, and then we need to snake a Ethernet cable right throughout the house, trying to get it, into some sort of main area that it's going to provide the best coverage. Where that starts to get even more tricky, right, is when there's multiple rooms, floors that require coverage, and now we're starting to get these fringe devices, I shouldn't say fringe devices, but devices on the fringe of the network, right, that require a good, reliable, consistent connection. And that could be that, solar panel outside or that solar system. It could be the EV charger in the garage. And oftentimes, right, we have kind of connected TVs that are scattered throughout the home, oftentimes, right, upstairs. Maybe there's a bonus room or something in that TV, that big piece of glass with which is an interferer, and all the little diodes, right, and electric interferers are in the corner of the house, yet it's the furthest away from the Wi-Fi, right, maybe another floor away, and it requires the most consistent connection to be able to stream video.
Mm-hmm. Hey, Kurt, I appreciate it. Helen had a comment, in the chat. She was talking about when we first install the fiber optic line, sometimes the ONT has to go to the corner of the house, and the DSL was a little different because it was in the middle of the house. And she said, she was great. She was like, maybe you should let us know that ahead of time, sometimes if it can't go in the middle of the house. But I'm assuming from her comment that she ran into maybe coverage issues because of where the router now sits, as opposed to where it was in the middle of the home.
Yeah, no, absolutely. Yeah. And that can be, right, a little bit of a challenge. The other piece is, right, because we don't know, right? It's a conversation with the customer in most cases. And there's, right, factors, obviously, with the construction of the home or the business, that right. we're running into in terms of where you can, logically wire. And again, right, the best place might be in the middle of the living room or right the kitchen too, where right. might not be ideal aesthetically either, right, where you don't want this equipment mounted. So that it's always a trade-off with the customer. So that's certainly a valid point. And when we say the center of your business and home, it's really not the center. It's really the center of your usage. Right. Where are you using, right, your devices the most, and where is the critical access, right? So that is different than, right, the physical center of your home, right, to get that. And again, right, any distance walls, etc., will all degrade the performance. I wish we could, but we can't defy the laws of physics. Mm-hmm. Newton's laws are still intact.
Right.
We've kind of looked at this, just a reminder of that, right? As you get through that sheetrock wall, or, that physical barrier, right, might be a problem. Chris, this is something that we wanted to just quickly touch on too, is that we run into more questions on. And, unfortunately, Wi-Fi calling is great when it works well. There's a lot of stuff that happens behind the scenes to make Wi-Fi calling work on a device and with the cellular network. And some of the things that we have found is, right, like some of the common issues are, right, could be poor call quality, calls drop, because they're switching back and forth, right? Might be on the fringe of the cell network. So we don't know what algorithm, right, Verizon, AT&T, T-Mobile, and others are using, on their networks in terms of when it makes a call over Wi-Fi versus the cellular network. Sometimes we find, right, Wi-Fi calling not working at all. So some of the troubleshooting tips that we see is, right, first of all, right, making sure that Wi-Fi calling is enabled on your device, especially if you're in an area of, right, spotty coverage. Making sure, right, your carrier settings and your device is updated to the latest software and firmware, and that's just a good practice across the board. And then again, right, it's going to prefer that 5 gigahertz signal much more than the 2.4, right? You want that less congested frequency. One of the things that we found is if you are having drops is to use airplane mode and Wi-Fi, where it's going to force that call, so the cellular connection is not even an option on that device. And I think, Chris, in many cases, right, that's resolved them, and that's usually that fringe, right, where that cellular, for whatever reason, it keeps picking up the cellular signal, even though the cellular service, as we know, can be pretty spotty in many locations within Vermont, and even right within different parts of your own home. But that is, I would say, one of the biggest things that we've seen. That helps people when they are right there home. I know it's a little bit of a pain, but if that's critical to what you're doing, right, that is one workaround when it comes to Wi-Fi calling.
Yeah, that is a great tip, especially in Vermont, where there's, you live in an area where your cellular calls are not well. That little tip can really help you out. You just got to remember when you get back on the road to re-enable, get it off airplane mode so you can get things going. But it works really well.
I would say one of the other big support calls that we see, is related to video streaming. And just, one point of clarification, there's a big difference between live streaming, which is like, you're watching, it's basically your cable TV service. Like if you're on our GMA video service or, any of the other ones that are out there where you're watching live TV versus video on demand type services like Netflix, where it's, you're downloading a big chunk of, static content. What that does, like a Netflix does, it's going to download as you go a big portion of that movie, and you have a big buffer, on the local device. With live streaming, you only have a couple seconds. So even if it's not a high bandwidth application, there, any type of Wi-Fi interference or, the RF spectrum in your house isn't just this straight linear line. It kind of ebbs and flows, with not only network usage, interference. It's just the way RF works, right? It's those sine waves. And what we see is, right, if you're on the fringe of the network with live streaming, that's where you start getting that buffering, which can be pretty frustrating. When you're just trying to watch TV, and oftentimes, right, that's poor Wi-Fi signal strength to that device and TV. I have a TV that I use for testing behind me here, right? It's this big piece of glass. Oftentimes, like if you're using, right, there's no big antennas on it. If you're using, like a Roku device or a Fire Stick, right, that plugs in on a dongle, it's usually behind that big piece of glass with all that electronic interference as well, right? LCD TV is made up of all these little diodes, electronic diodes as well. That's creating all this noise and blocking that signal as well. So it can be everything from, just the distance from the access point, the physical barriers that we've talked about, electronic interference, and all the above, right?
It's actually remarkable that it even works, video streaming with the Roku device behind the TV, yeah.
I wanted to talk a little bit about speed tests too, Chris, right? Like speed tests are, everybody loves to speed test, right? To see what things are looking like. And, the challenge is just understanding what a speed test is looking at and what they're actually good for and not good for. So, they're a helpful tool, but they don't tell the whole story, and not all speed tests are created equally. So first off, right, they're definitely good to give a quick snapshot of your connections download and upload capacity at any specific moment in time. The challenge, I think, is that we're really, in many cases, testing the Wi-Fi performance. If you want to test the internet speed that's coming into your home or business, you really need to test from the main router or gateway. And there's some ways to do that, which we'll show you. Command IQ app we'll talk about. If you're on one of our Calix fiber optic routers, it's an app you can download that you can it'll run the speed test right from your router out to the internet. So it kind of takes away any device issues, device performance issues, and Wi-Fi issues. So it's truly testing the speed of your connection. And some of the things that we see is device limitations, right? Those older devices or Wi-Fi interference can really skew results. And there's, when it comes to consistent streaming, right, jitter and latency are critical for video, right? That buffering piece. You might be getting a perfectly good or adequate speed test to that device, but the fluctuations behind the scenes and what they call jitter and latency on that Wi-Fi connection might be what's actually causing the buffering. So one of the things that I just want to mention, with a vast majority of our customers now on fiber, we can take a look at the light levels down to the ONT. So right at the optical network terminal, that's either outside or just inside your home. It's the first powered device, and that's that device that connects or converts the optical signals from the fiber optic glass to electrical signals. But like this one, we can see the light levels. And then we can see the trend line. Like you can see there's this device was offline here for a period of time, probably some sort of power outage or a fiber cut. But you can see how the optics are perfectly pretty much a straight line. And we can see the strength up here, that's probably as perfect as a connection as you can get. So, the next step obviously would be to take a look at what's going on the actual router, right? Which is the next piece of equipment in the chain. But I would say if we saw this on an ONT, Chris, we can guarantee the speeds to the side of the house, and it's not going to be an internet connection issue, right? Because this is pretty much as close to perfect as you can get. As I mentioned, right, we have the ability to, we have some service provider visibility tools that allow us to speed test from your gateway. Also, as I mentioned, we're going to talk about the app that allows you to do that as well. And that gives you, we can see things like, uptime. Like this router was up 24 days, 4 hours, 22 minutes. So if somebody's complaining about drops, first place we look is the ONT. We saw that was online and there was no offline periods. And then we can go and look at the uptime of the router as well. And then again, it looks like this was probably a 100 meg service. This was provisioned for, and, it speed tested 103 meg down, 97 meg up, which is, pretty much, right where it would be. So we already talked about a bunch of this stuff, other things you can do, right? Move those cordless phones away from your access points, things like fluorescent phones, compact fluorescent light bulbs, those metal appliances, mirrors, just if you're setting up a new access point or moving or creating a mesh network, just things to be aware of. If you do have a Wi-Fi extender or repeater in your network,
get ready.
I think we see these, Chris. The first thing we do is unplug them and
yank them
and recycle them. They're terrible, right? They're typically just taking a poor wireless signal and repeating it. And the other piece, they confuse the network and they really confuse devices. There's much better equipment available out there to put in multiple access points that within a home that all work in a seamless network, and we'll show you some of those coming up here in a minute. This is a download an app, and I think it's free, Chris, right?
Yeah,
that you and I use. I think some of the techs might use it as well, but it's a really nice way to check your Wi-Fi performance. Available on the Google Play Store if you're an Android user, or the App Store if you're an iPhone user. But it allows you to kind of download the app, and it's just basically doing what it's testing is a speed test from your phone right, to your Wi-Fi router. And what it tells you is what's important is where you see the dips. So if you were to walk around your house looking at the app, you can see where your Wi-Fi, maybe you go around the corner over by a TV and you see a drop, way down, that's going to require some attention, right? That might be why you're having some issues, with that streaming service on that TV. The other piece that we like to talk about is just making sure you're running some, antivirus software. We've seen cases where viruses, adware, spyware running in the back of the ground just makes your entire network really unusable. The good news, if you're one of our fiber customers and you're using one of our Calix Gateway, we do run a product called Protect IQ behind the scenes on it. That is actually blocking a lot of the threats. But again, so it's protecting some level of protection on the network. But again, it's also important to protect your devices as well. So, we're constantly, obviously, hardware is not static, right? There's new vendors out there, there's new standards out there, and we work really hard to try to keep up with, what's working best, for our customers. This is what our basic standard fiber installs look like. You'll see that on the left there, that black box is the optical network terminal, and it might be some variant of that. But that's basically right. The fiber cable connects into that, and then the copper Ethernet cable is going to come out of there and then connect into the back of. In this case, this is what we pretty much our standard fiber install. This is the newer ones. You may have one. Oh, I don't have one here. I thought I did. The other ones are like square, which is just the same variant. This is just a .2 version of that same box, but they basically have the same electronics in the box. It's just a different case. A two-port router, right, on these, pretty much standard Wi-Fi access point that provides really, really pretty good coverage, Chris, right, through most homes.
Those are great devices. We really like them.
The next step up is kind of U6, right? It's got a 2.5 gig WAN point where we're not offering in most areas multi-gigabit fiber speeds yet, just because there's not a huge demand for them. It is capable of up to 2.5 gig. And it also has 4 1 gig WAN ports, so a couple more ports than the U4 has on it, right? These are all Wi-Fi 6 devices, so right, those dual bands. We do have some of these out there, Chris. I know you've used these in small business situations or for customers that need a few more ports. We have this device. It's a little bit more expensive, but we do have these U7s available. And again, that has a 10 gig WAN port, meaning that right down the road when we're offering 10 gig packages over our fiber, right, it is capable. And this box has the new Wi-Fi 7 built in, so it's actually a tri-band. I don't have any devices, Chris, that are Wi-Fi 7 capable yet.
No, me either. I mean, we are putting access points that are Wi-Fi 7, but none of the devices yet are.
There's a few, I think, out there, some of the newer stuff, but the majority still aren't. The next thing we want to talk about, so any of these Calix gateways, the great thing is they can provide basically a whole home Wi-Fi network in your home. So if you do need additional coverage, right, we can use, any of the U4s, U6s, that U7 can all basically mesh together either via a wired connection or via what they call wireless mesh. We can set them up, and that'll act as one single network name in your home and just provide additional coverage where you need it. Chris, I know you do a lot of work setting up these whole home Wi-Fi networks. Anything else you want to add?
No, I mean, I will say that they mesh well, but there are times when I will run a wire from, the bigger device to the smaller device. So that's, again, getting back to wired is always better than wireless in some cases, or good wireless networks need good wires sometimes, to connect them.
I know another tool we have in our toolboxes now, where folks, maybe they want to extend their network out to that EV charger or to, the solar panels and, it's on the fringe of the network or, that outdoor deck space they may have. We now have, Calix makes a U4 that's outdoor rated that we've been using. And again, that can be wired or use the wireless mesh to the existing router that's in the home and just provide that seamless extension outside. So pretty cool stuff.
Mhm.
So many of you guys use our Smart Hub bill payment service, right? Where you can log in on our website and you can view and pay your bill. Just last week, a new feature came on where you'll see a managed devices tab within Smart Hub when you log in to your Smart Hub account. And if you have one of those Calix gateways, it's now showing your connection status. You have access to your Wi-Fi settings, like if you wanted to change your SSID, your Wi-Fi network name, Wi-Fi password, wanted to set up guest Wi-Fi. You can reboot your router in there. You can see your connected devices and signal strength in there. So it's some cool stuff, right, that we're seeing with just the level of integration across the spectrum. But if you do have an existing Smart Hub account, you can just log in and again, right, if you have one of our Calix routers and it's assigned to your account, you get just a little bit more control to make it a little bit more convenient to both troubleshoot or set up some basic functions. At the same time, this is a free app that you can download to your again your iOS device or your Android device via the Google Play Store. If you search for Command IQ, all one word, you just basically scan the QR code on your modem. So if it has to be a Calix router again, but if you're one of our fiber customers, you're probably using one. On this one, right, the U42, it's kind of hidden under that plate, but there's a QR code there. After you download the app, you just scan that, and it will get everything set up. And again, it provides even more granularity. You can see what Protect IQ, what threats it's blocking. You can do all those things, set up a parental controls. You can set up a guest network. You can change your SSID. You can see your connected devices. What am I missing, Chris, that it can do? I think you can get really granular, like creating profiles and stuff, right,
Yeah.
within and rules.
Yep. Is it content like sensitive? Can it filter content and that sort of thing?
You can,
yeah.
To some extent, if people want to really get granular. Todd, who works down the hall from us, I think he's probably the biggest user of Command IQ, and he's got, like, I looked at his one day, and he's got like everything set up, all this port forwarding, all the really complex stuff, and I'm like, okay, yeah. So you're the heavy user, but it just gives you a lot of control over your network and makes that easier. This is another feature that just rolled out. Hopefully people don't have to use it ever, but it is there and available. And that is you can actually set up basically mobile backup via the Command IQ app, meaning you can set up your cell phone if you have decent cell service. So if for whatever reason your fiber connection ever went offline, it can then keep your entire Wi-Fi network online via tethered to your phone as a mobile hotspot. Obviously, data charges would apply if any apply on your account with your cellular provider, but it could come in handy if you work from home, or you think of the other big use case, Chris, right, would be you work with a lot of small businesses, restaurants, point of sale systems that they may be running that are connected to that. And
it's critical.
You can't afford any downtime, but it is kind of a cool, just some additional resiliency. Again, hopefully, we do have fiber cuts from time to time. This time of year in Vermont, there's a lot of construction going on, a lot of digging, and things do get cut, right? It does happen. So this is an update that we just pushed. It's a feature that's in there, and it's can be set up via that Command IQ app. Chris, I know you do a lot of work. There's a lot of different equipment that we use in business applications. That's just, again, most of the other equipment we showed is perfect for pretty much any home, small office. But sometimes, right, we get into, applications where, like thinking like up at Sugarbush, Clayburg, we have what, 25, 30, maybe more these days, access points throughout the whole campus. And, that we do typically reach for some different equipment.
Yeah. The biggest difference with these is, they're a little more enterprise. They can handle more devices. There's some management in there where we act as the IT folks. So that's this line is really for a small business and medium-sized business.
And it's a little pricier, obviously, equipment wise as well. Another thing I just wanted to talk about, right, is just battery backups. When we're talking about redundancy and resiliency within your home or office, obviously, if you have a fiber optic connection, if you have our voice service, we do put one of these backup batteries in, and what they say is it's up to 8 hours of standby power. Obviously, the more you use the connection during a power outage, the more battery it's going to use. We see obviously more and more homes and small businesses with, whether it's backup generators that provide, power to everything, or even, some cases with solar and, the whole home battery systems, that provide, that additional redundancy. But it's not just the O&T that you have to worry about, right? It's any of those additional Wi-Fi access points, that router, and then think about, any of the devices that you might be needing to use during a power outage. So, while this battery up at top is the ones that we offer, again, it comes standard if you're on fiber with us and you have a phone line. If you have an internet connection, and you can pay for one, and it's optional. And these actually you can stack, I think, up to 3 to give you up to 24 hours backup power for your O&T. But these little UPSs, right? I got one under my desk here, connected to my computer here. They're what, $55 starting point,
55
depending
to
on how
100.
big of a battery you want.
Mm-hmm.
But again, not only does it provide that backup power, but it's also supplying clean power, right? In the case of fluctuations that you may see, the brownouts that you may not even know about. It helps to smooth out those power. And, last night, I don't know about where you were at, but my house, we had some wicked thunderstorms already last night. So, those power outages are coming. So again, just a good best practice to think about, especially if you work from home, or you have a small business, or, you rely on your internet connection for mission critical stuff, which, many of us do these days. These pictures, Chris, are just some of the business installations that we've done over the years. Every install is really different, right? Whether that's in a home or business, our techs are pretty good, about figuring out that placement and where things need to go, and if additional Wi-Fi access points might be needed. Yeah. So, I mean, we've covered a lot of ground, Chris. So
yeah, you did great. That's quite a bit, and we're just under. So we do have time for a couple of questions. I have been answering questions, I think, along the way. I've given out my email address. Everybody should see that. If you have any questions down the road, please reach out to me directly. But Kate had a good question. Kate says, I got the fiber update in New Haven a year or so ago. Is it possible she doesn't have a router? I'm pretty sure she gave her router and doesn't have another external box. What do you think of that?
So there are some that are all-in-one units that we have used. So it might have the optical network terminal combined into a single box, but you would need to have some sort of router. We do find some customers, right, that don't want to use our router, and that's perfectly fine. Obviously, we lose some ability to help troubleshoot that and some of that service provider visibility tools. So I don't know if it's possible that you had your own and kept that one and plugged that in. But those are, I would say, you have some sort of router. It's just whether that's, when you had one we provided, but it could have been an all-in-one solution as well.
Yeah,
we haven't been using them as of late just because of we like the 2-part box better. they're just a little bit easier to, mount that optical network terminal in one location and then wire to the, a better location for these versus trying to find a place to run the fiber, an adequate location in the house. So we've
Right.
kind of moved away from the single box solutions for the most part.
Yep.
Not that there's everything has its pros and cons, but that was a little bit easier sometimes with the text to be able to separate the two.
Mm-hmm. I had another question. Scott brought up, I think it's interesting. Can you discuss the need to reboot the router and mesh units? And boy, I'd like to know a little more detail if you're having to do that a lot, Scott. What do you think of that, Kurt?
Yeah, I would agree. Usually a reboot, obviously any electrical, right? Electronics things can go dumb and require a reboot, but it shouldn't be something that's regular. What
Right.
may happen sometimes is if there's a mesh unit involved, oftentimes if it's at the fringe of that mesh network, where it's got a good mesh signal, the big key with mesh is that second access point needs to be within a strong Wi-Fi signal area and then propagate into that area where where there was low signal strength before. If that mesh link isn't, sometimes it'll
fringe.
just get stupid trying to go back and forth. It also could be a faulty mesh unit, right? If it's needing to be rebooted too often. Chris, I don't know if you want to drop in off your contact information in the chat, and
Absolutely.
we can certainly take a closer look and help troubleshoot that. But that I would say if it's happening regularly, that shouldn't be happening.
Right. And that's something, Scott, that because you have our stuff, we can see some visibility. So we can, when it is connected, if you wanted to call in sometime, they could tell you like, hey, it's got a strong signal or it doesn't have a strong signal. So that could give us a big clue as to whether it's about placement or if it's just about a bad unit. That's all I really have. People are checking out and thanking us, Kurt. They think you did a great job, so that's great. I have given my email information out, so I encourage anybody who wants to talk more offline, reach out, and we'd be glad to help you in any way. Helen, if you have questions about that wiring, reach out to me as well. Thank you, everyone. Appreciate it. Kurt, thank you.
Yeah, appreciate it, everybody. Thanks for being a customer and have a great day. Hope this was helpful.
Take care.